So for starting this project, first you need to upload your notebook to Google Colab if you are working in the Google Colab, or you can directly do in your Jupyter notebook. Then simply upload this file. This is in the chat, you can simply see this file you need to upload. I have already uploaded here, so then also. Then first I have imported the warnings and ignoring the warnings because there might be some like packages or other issues in the libraries, so it would ignore all those warnings. Then I installed the XLS writers because I need to make an Excel file as you told me earlier. Then simply run this one. Then these are the library which is needed to do the packages and these things like ARIMA, TensorFlow, Sequential, LSTM and DENS. Then first we loaded the file, which was this is our name of file. Then we made a data frame and we skipped 3 lines because the first 3 line was not good to make the columns. Then we made the columns like year, month, state, residential review. These are all 4 things from all the 5 of things: residential, commercial, industrial, and transportation, and then total. Then we made the data frame columns using assign the data frame columns to the columns. Then we check the string if there are any like not available or missing value, we are just making them as unknown. Then simply we drop the null values and check the like year and month are integer format or not format. Then we checked for the data status, which was needed to be string. Then we made a x month, which is simply like month 1/year. So it would be like which month and which year of this is exactly. Then we made new columns which only include year, month, state, x month, the data status, residential, commercial, industrial, transportation, and total. Then we name that as a state sales XLS. Then we simply use a pd.xl writer and we use XLS writer engine here. Then simply just make for each state, we are just making a new sheet for in Excel, and inside that there are these columns, and simply just check in the last we are checking for 31 character, because if it is more than 31 character it would not be written in the Excel. Then simply just run this one and Excel is updated. So this is how we made the Excel. You can simply check this, it would be automatically generate. Simply click on this one. Okay, for AL, ARC, California and other things, there are all the available states data inside this one. And this is also date format if you see. So it is like 2010 to 2024 data inside this one. I'm cutting this one and coming into the next one. Next I check the data set again by head of this data set, and these are the things we have. Then first we check how all the unique states from the data set. So these are the states available in the data set. So I guess 1 2 3 2 3 4 5 6 7 8 9 10 11 12 13 14. Okay, there are approx 54 states I think. Then we need to get only the specific one like California, Florida, I think Texas, New York, and WA. I am not meaning the full form. Then we just check is it included or not included. These states should be included. Then again we check for unique values, and these are the only things left in this one: CA, Apple, New York, Texas, WA. Then we again check the data frame. Is it true or not true? Then simply just we got this one. Then we visualize these things. Now for the visualization, we make a trend line. Let's see, like it is making from 2010 to 2024. So this is a forecast value which is exactly like it is doing or not doing. Then it is the trend line would be come from the starting point and the end point. For all the states it is just showing this like this, like for WA, for Texas, for New York, for Florida, and for California. Okay, now coming into the next thing. Next thing we need to do the modeling part. So we need to prepare our data for ARIMA and LSTM. So for the data preparation, we use only these columns, like date and total sales. And date should be set as an index, and total sales should be as a megawatt. And this should be also a float value. And then we need to implement the ARIMA. For ARIMA, we use this order 510 with the state data, and just simply use the model.fit, and we use the forecast for step bar on return this one. Same like LSTM. For LSTM, first we need to do the scaling of the data, and the feature range should be in the between 0 to 1, and we need to transform the scale data and then reshape the data into like a 2D variable. Then we prepare the data using 80% of the training data and 20% rest of the test data. Then we create the data set. There are this is a local function for the creating data. Then there is like a x and y variable for in the range of the data. There is like for the each time step we need to append A and then append B, and this would be like a time step 1, and then we created the data like x10 and y10 using this function, and x state and y state using this function. Same like x10, and then we need to reshape because the data is not good for the providing the model right now. Then we need to create the sequencer model first. We give the 50 like 50 layers for the first, and then it is like sequential layers, and then we give the 50 again 50 layers, but it not sequential layer. Then we give the one dense layer, and we compile the model using mean square error, MSE errors we need to show, and then we fitted the model using x10 y10 and with the 50 epochs, and our batch size is 1 and what basis 2. Then simply get the prediction, and after getting the prediction it would be a scalar mode, so we need to inverse transform that first, and we just return the prediction. So state in the state there are only 5 states there, so we just do the for each state we need to first get the state data frame, then we convert the date time x date to month, date, year. Then we got this to prepare the data because we already made the function for that one, and we got the ARIMA prediction for using the ARIMA forecast model, and LSTM prediction using the LSTM forecast model, and just plotted the things what we got. So these are the things we got. So if you see in the 2012 10 to 12, the green line is our LSTM model, which is approximately making the sense, like for the forecast node 1 it is approximately matching the our forecast value, and in the below one also for WA it is also million, but the ARIMA model is not working as a good one, because if you see comparison this is not going that deep, but that should be it only. So ARIMA is not good in this case. So next coming into the like transformer things. So first we need to install the other things like which is required. So transformer is required because as you said like we need to use Hugging Face transformer with a torch. So we install the transformer torch, and then we again need to prepare the data. As I told, we need to use for any kind of deep learning we need to first do the scaling of the data. So again the scaling of the data we need to use the fit transform scalar method, and our target is total sales and in the megawatt hours. Again created the xy, and in the range of the sequence length we need to create the x and y for our data set, and we just provided x, y and the scalar in this function. Then get the sequencer dictionary, and inside that one there are like total 5 states. For each state we are doing the same thing, x, y and scalar from our states, and we just doing the appending in this one and checking the size of this one. So our input size should be 161, 12. 12 is for 1 year, and output share should be 161. and then we define our new LSTM model which would work on the transformer. Same like thing, but now for the prediction we got the like only shape one and one shape, and just modeling the LSTM and fitting the model and getting the prediction as a scaled model, and then after the scalar we need to inverse transform and get the prediction for each state. So this is the what we got. Should we go below? Okay, so for the if this forecast we got this value for forecasting in something in megawatt, then we need to visualize the forecast. So after getting the visualization, this is the end point for this one, like after 10 years this would be like a ending point for rad means it is getting the for the 2024 to 2038, these are the value we are getting for this one, but in this is the rad is a like ending point for this one. But now in the other sense we are just again doing the next forecast for this one. So after that we are getting the more prediction for the more prediction we are doing for next 10 year for 120 months, and checking the last sequence is available or not available, then just getting the values for that one, and yeah, these are the values, and just again the plot at the things. So after the 2038 these are the values we are just getting, and we are just getting the a similar pattern of like only a single line after that, because the model has a limited thing. For the New York also these are the things, and there are other things also, same like for Florida, California, and West Africa I think. Okay, and then we need to do the RNN model here. So we use the simple RNN method here, and again we define a new method, build RNN method. Only one layer has been removed, and the activation layer is our ReLU layer. So again doing for prediction here, same like LSTM it is working, and what we got something like forecasting value of 2100 and something in megawatt. So again mean absolute error, as you told we need to calculate the MEP. So for MEP we got these value. For LSTM MEP is approximately 0.08, which is very less, so it is good, saying as a good one, and LSTM it is 0.11, so it can be also said good. So these are the things we did, and that's it.